Okay, so in example 2, we've got an ellipse. Remember, an oval in algebra is called an ellipse. And the domain is all of the possible x values. So as I look at my lowest possible x value for this ellipse, right, I've got a point here as far left as I can go, which is at -1. And then these x values are continuous, right? There's no breaks, holes, or gaps in this curve of the ellipse all the way over to its highest possible x value, which is at 3. So the x values, the domain, those are continuous, all the possible numbers from -1 to +3. And we're going to write that as an inequality. So we would know that the x's here are greater than or equal to -1, and the x's are less than or equal, going this way, to 3. So x is less than or equal to 3. Okay, when you have an and inequality, you can write that with your lower bound, -1, then less than equal to x, less than equal to 3. So this says that x is between -1 and +3. Right? It includes all the decimals and fractions that fall along that continuous pathway between those endpoints. Okay, the range, we're going from bottom to top. So y values, our lowest possible y value is here at -2. And it's continuous all the way up. Right? As we go across here, all these y values are part of the range until we reach the highest one at +4. So the y values are between -2 and +4. Right? The y's are greater than or equal to -2, and the y's are less than or equal to 4. Okay, does this ellipse pass the vertical line test? No, it does not. So this is not a function. Okay, when your interval has real number endpoints, so for instance, the domain is between -1 and 3, right? The range is between -2 and 4. Those are real numbers, and that we call a bounded relation. A bounded interval. So we have a bounded interval for the domain and a bounded interval for the range. Okay, in example B, the domain is our possible x values, and the open circle here at -5, that indicates that it is non-inclusive. So open circle, non-inclusive, that means that the lower bound here on the domain, -5, is going to be strictly less than the x. We won't have an equal sign with it because it's an open circle. Okay, now the upper bound of the domain, the highest possible x value, is a closed circle. So the x's are less than or equal to 1. Right? So in this bounded interval, the lower bound, -5, is non-inclusive because of this open circle. The upper bound, +1, is inclusive because it is a closed circle. Okay, now let's take a look at the range. So the range going from y values least to greatest, our lowest possible y value here is the open circle where y is 0. So we're going to start with 0, strictly less than y, right? We will not include an equal sign there because of the open circle. Now our highest possible y value is up here at +3. That's a closed circle, so it is inclusive. So we have a less than equal to 3. So our y's are bounded between 0 and 3, non-inclusive at 0, and inclusive at 3. Okay, this line segment does pass the vertical line test, and so it is a function. Okay, let's try this third example. So here we've got a piece of a cubic function, and our lowest possible x is at -2. That's a closed circle, so we're going to use a less than equals. Okay, then our highest possible x value is +2. That's an open circle, so we're going to keep non-inclusive on that endpoint. So our bounded interval is between -2 and 2. The -2 is inclusive, and it's open on the right side, so +2 is non-inclusive. Okay, now the range, bottom to top, right? We're going lowest possible y value to highest possible y value since it's continuous in between. So our lowest possible y value is a -3. Right, that's down here at the bottom, and then it's continuous up to we reach the highest possible y value at 5. Now, there were no open circles along that path, and so we assume they're closed. So we're going to use a less than equal to for both of those bounds. So our bounded interval for the range is -3 to 5, and it's closed on both ends. Okay, this passes the vertical line test, and so it is a function. Okay, so take a second and try these two examples on some scratch paper or on your whiteboard, and when you're ready to check your answers, you can resume the video. Okay, so let's see, we've got a domain of -2, -1, 0, and 3. Right, this is discrete data. It's individual ordered pairs, which makes a scatter plot. The range of this data is -2, 0, and +2. Those are our y values. And the scatter plot passes the vertical line test, so this discrete data is a function. Okay, now looking at example B, our domain, we're going from -3 to +3, and we can see this is an open circle here at -3, so there's no equals. -3 is strictly less than x. We have a closed circle at +3, so that end does get an equals. So the x's are less than or equal to +3. So bounded interval, open at -3, closed at +3. For the range, we're looking for the y values, least to greatest. So down here at our lowest point on this semicircle, right, that's at y equals -3. There was no open circle, so we assume it's closed. So -3 is less than or equal to y. Now, as we come up to the highest possible y value, right, that's here at 0, and we've got an open and a closed circle. So it is going to be included because it's closed at one of the values. If both of these endpoints were open, then it would be non-inclusive. Okay? But because one of them is closed, we're going to close that upper bound.